Alright students, today we're going to work on section 5-6. You're going to need your papers 299 through 303. Get them tore out of your book and get ready if you haven't already. Give you a few seconds to do that. And be thinking about what we've been working on. We've worked on ratios and rates and unit rates, and today we're going to compare some unit rates. Alright, on the solve and discuss it says Rick and Nikki own remote control cars. They use a stopwatch to record the speed of each car, whose car is faster. So we can tell on this first table right here that Rick's car will go 150 feet in 30 seconds. But that doesn't tell us how fast it goes in 1 second. So we're going to figure that out in just a minute. And Nikki can go 80, her car can go 80 feet in 20 seconds. So we need to go find a unit rate for both of these, which means that we need to turn this 30 seconds into 1 second. Well, if we divided 30 by 30, oh, my pen won't write. If we divided 30 by 30, it would give us 1. But if we divide this number by 30, we have to divide this number by 30 also. And 150 divided by 30 is what? 5. 5 feet. Okay, let's go do the same thing over here. Let's turn this seconds into 1 second. So let's divide this by 20. 20 divided by 20 is 1. And whatever we divided this by, we have to divide this by the same thing. 80 divided by 20 is 4. So Rick's car speed, its speed was 5 feet per 1 second. Nikki's speed was 4 feet for 1 second. Now you tell me which one's faster. Who's covering more ground? Who's going further as far as feet in the same amount of time? See, when we have these the same, when our denominators are the same, we can compare the top numbers. The numerators say this one's 5 when this one's 4. So this one's going a foot further every second. So let's say that down here. Rick's speed, and right above that we're going to put rate, because rate is speed. Rick's speed is 5 feet per, the word per means a division line, per 1 second. And Nikki speed or rate is 4 feet per every 1 second. Okay, abbreviation for feet is lowercase ft. Abbreviation for second is SEC. And you have to get this right. Feet per second. That says feet per, I'm saying the word per, P-E-R, feet per second. Feet per second. Okay? Now, so when you're in a car and you look down and your mom's going 55, she's going 55 miles per hour. That means miles is in the numerator, hours is in the denominator. Okay? Now, I don't think it's too early in your career for you to learn a formula. which is, and I'm going to put it right over here at the side, distance, which is a lowercase d, is equal to rate times time. These are all lowercase letters in this formula. A lowercase d stands for distance. If it was an uppercase d, it would stand for density. So you have to use the correct form of the letter. R stands for rate, which is speed, and T stands for time, and it can be in anything, hours, seconds, anything that has to do with time. Okay, now I'm going to show you a little thing that we did. Right up here, see this 150, which is distance, and this 30, this 150, which is distance, and this 30, which is time. Look at this formula. If I put the 150 in right here for distance, and I leave the R there, times, the time was 30. There's an equation. And if I was to put that 30 in front of the R like that, now we know that we're supposed to divide both sides by 30. And when we do that, we get 5 is equal to R. Isn't that what we got right here? 5 was equal to R. Right here. There's where we got the 5. And it was the rate. Now then, this 150 was feet. I'm going to squeeze these units in here. And the 30 was seconds, SEC. So when I get through, my rate is 5 feet per every 1 second. Did we write the 1? No, we didn't write the 1. We did right here, but we don't have to write it. It's just 5 feet per second. Now, this leads us to something I want to show you. Let me make this smaller. Distance equals rate times time. I have a little chart here, and actually let me make it smaller for you so you can see the whole thing. Distance equals rate times time. And at another school, I did this. I made a little triangle, and I put a line this way, which means divide, and I put a line this way, which means to multiply. And I put the D here, and the R, and the T. So distance equals rate times time. But if I have distance and time, I'm going to divide to get the rate, because distance is in the numerator, time is in the denominator. If I have the distance and the rate, I'm going to divide to get time. Take distance and divide it by rate to get time. If I have the rate and time, I'm going to multiply those two, just like the formula says right here, to get distance. So there's 3 formulas you can get from this. Distance divided by rate gives you time. Distance divided by time gives you rate. And distance equals rate times time. There's the 3 formulas that you can get from this little picture right here. Remember, this means to divide, and this means to multiply. Okay? All right, let's go to focus on math practices at the bottom of the page. Make sense and persevere. If each car maintains its rate of speed, how long will it take Rick's car to travel 300 feet? So I know I've got a distance of 300 feet, F-E-E-T, and I know my rate up here, looking at what we just did, his rate was 5 feet per second. So I just told you a minute ago in my little picture that distance is equal to rate times time. Well, what if I'm trying to find time? It says how long will be time. If I'm trying to find time, I need to take the distance and divide it by the rate. So I need to take 300 feet, and I need to divide it by 5 feet per second. And that's going to give me time. Well, 5 goes into 36 times, and it's going to have a 0 on it. So time is going to be 60. My feet are going to cancel and leave me with seconds. It's going to take 60 seconds. Okay, so I wrote down what I had. I've got distance and I've got rate. I'm trying to find time. I look at my little chart. If I'm trying to find this, then I'm going to divide these two. Okay? All right. Turn the paper over. Example number 1. Let's go through this. Ethan swam 11 laps in the pool in 8 minutes. 11 laps. This must be Ethan right here. Austin. So this is Ethan. This is Austin. Austin swam 7 laps in 5 minutes. Which boy swam at a faster rate? Now, is the faster rate a fewer number of laps per minute or a greater number of laps per minute? It's going to be greater if you want the person that swam the faster. Okay, now this gets a little bit ugly, and I hope you have some calculators in your room to do some of this so it doesn't take you too long. But look at Ethan. We're going to take and divide this bottom number by 8 to get a 1. And so you can see that when we take 11 and divide it by 8, it's going to give us a decimal number. But this still is a unit rate. And then when we do this one over here, we're going to turn that bottom number into a 1 by dividing the 5 by 5, because we want it to be a unit rate. So whatever we divided the denominator by, we must divide the numerator by. Well, when you take 7 and divide it by 5, you get 1.4. Now, which one of these numbers is bigger, 1.375 or 1.4? Well, of course, it's this one right here. So he swam at a faster rate, because this is like 1.400 if you want to compare like decimal places. All right, let's do the try at the bottom of the page. Ashley is Austin's older sister. She trains at the same pool and she can do 9 laps in 6 minutes. So it's this denominator we need to turn into a 1. So 9 divided by 6 is, 6 divided by 6 is 1. Then on the top we have to do the same number, use the same number we did down here. Well, what is 9 divided by 6? Use your calculator or do it by hand, and I get 1.5. So this is 1.5. Okay, Ashley swims 1.5 laps per minute because, be thinking. Okay, can you follow their plan? Because 1.5 is greater than 1.4, Ashley is a faster swimmer. So if they were in a race, Ashley would win. All right, let's go to example 2. Is the lunch special or the weekend special a better value? Find the unit price of each special. The unit price is a unit rate that gives the price of one item. Okay, so we know that 3 tacos cost $2.40, but we want to know what 1 taco cost. And they made you a little chart right here. 3 of them cost $2.40. So if I take 3 and divide it by 3, it gives me 1. So I need to take $2.40 and divide it by 3. Well, what is $2.40? $2.40 divided by 3. You should know that that's 80 cents because 24 divided by 3 is 8. So that's going to be 80 cents. So to find the unit price of the lunch special, find the cost of 1 taco, and they did it right down here. They got 80 cents. Okay, I didn't put my dollar mark on that. All right, so let's go over here to this one. 4 tacos is $3.40, so we need to divide this by 4 to turn it into 1. We need to divide this by 4. So $3.40 divided by 4 is 85 cents. So this one costs more. Okay, and it shows you that right here. Okay, so which one, let's see, what was the question? Find the unit price of each special. We did that. All right, let's go down here to the try. It didn't ask us, did it ask us what was the better value? Oh, it did, right up here. Lunch or weekend is the better value. Well, the 4 tacos cost more, so the lunch was the better value, and it said so right here. the 80-cent tacos are cheaper than the 85-cent tacos. All right, let's try it. Explain how to decide which is a better value. So I need to know the price of one cream. I know $10 for 4. So I need to divide this by 4 and divide this by 4. I need a 1. I need to know how much it is for one card. So what is 10 divided by 4? $2.50 for one card. Over here, we're going to pay $14 for 6 cards. So we need to divide by 6 to get an equivalent ratio and see how much one card costs. So 14 divided by 6 is $2.33. Okay, so explain how to decide which is the better value. We found the unit, if we want to explain it, we found the unit price per card. So find the unit price for each card and compare. Find the unit price for each card and compare. All right, let's go to the key concept. Let's see if we understand what we did today. We're going to use unit rates. That means when we get the bottom number, the denominator, to be a 1, we can compare the numerators. So $8.50 per 1 hour is greater than $8 per 1 hour. 7 laps per 1 minute is less than 9 laps per 1 minute. 32 centimeters per 1 second is less than 45 centimeters per 1 second. It gives you some examples. All right, so let's go to the do you understand number 1. How can you use unit rates to make comparisons? Compare the numerators of 2 unit rates. You're supposed to know that a unit rate means the denominator is a 1, so you can compare the numerators. All right, let's go to number 2. Paul says that a lower unit rate is better value only if you can use all items purchased to get the lower unit rate. Do you agree? I'm not sure I understand their question. Paul says that a lower rate is better only if you can. Well, yes, if the unit rate was lower but you didn't use all the stuff, then yes, I agree with that. Yes, you need to use all the items of the lower rate to make it efficient. I think that's what they're wanting. You need to use all the items of the lower rate to make it efficient. Make it worthwhile. Okay, number 3, car A. We're going to make us a little chart. Here's car A. Here is car B. car A travels 115 miles on 5 gallons of gas. If we want miles per gallon, then we have to put miles on the top and gallons on the bottom. Car B is 126 miles and using 6 gallons. Now we want to see which one gets better gas mileage. So we're looking for the one that uses the least amount of gallons per mile. Okay? So we're going to divide this by 5 and divide this by 5. We want to know how many miles we can go on 1 gallon. So I need 115 divided by 5 by hand or with your calculator, and I get 23 miles. And then I'm going to divide this one by 6, get 1 on the bottom, and I need 126 divided by 6, and I get 21. Okay? So, who can go further on a gallon of gas? Well, that would be car A. So how can you find which car gets better gas mileage? The one that goes farther on 1 gallon of gas, which is car A. We want to be able to get farther down the road on the same amount of gas. And this is what one of the facts that car dealerships will use when they're trying to sell you a car. Oh, it gets 30 miles a gallon, or it gets 28 miles a gallon, compared to this one over here, it gets 15. Why? Because it's going to cost you less money when you put gas in it. It's going to cost you less because you're going to be able to go farther. All right, do you know how? Hakeem's car travels 600 feet in 20 seconds. Andre's motorcycle travels 300 feet in 12 seconds. Which is faster? So we need to divide. We want to find the unit rates, and then we will compare the unit rates. So let's go find. I'm going to use H for Hakeem and A for Andre. So Hakeem is 300 feet in 12 seconds. So we want to divide by 12 and divide by 12. And we're going to get 1 on the bottom. And what's 300 divided by 12? 25. So we're going to get 25 feet, FT, in 1 SEC. Let's do Andre. Oops. 312. That was Andre. We're going to change our letters right here. That was Andre. Hakeem is 600 feet in 20 seconds. You probably noticed that in class. Good job. So we're going to divide top and bottom by 20. Divide by 20. Divide by 20. So we're going to get a 1 on the bottom, 1 second on the bottom, and we need to know what 600 divided by 20 is. If you can do it in your head, do it in your head, but don't lose a 0. So you got 30 feet. Now, in part B, they want us to compare. Who's faster? Which numerator is the bigger number? Hakeem goes 30 feet in a second, and Andre only went 25. So Hakeem is faster. Okay? And we do this as individuals living in the real world. We do this kind of stuff all the time. Real life problems. Sorry I got those mixed up on you. Give you a second to get that straight. And that's true because 30 feet per second is greater than 25 feet per second. When there's not a number in front of that second, it's a 1. You don't have to write the 1. All right, let's go to 5 and 6. Find each unit price. We got 7 movie tickets for $56. I want to know the price of one. So it's $56 for 7. Divide by 7, divide by 7, and you get a 1 on the bottom. And what's 56 divided by 7? You should know that's 8, because 8 times 7 is 56. Okay, so there's unit price, $8 for one ticket. All right, we got 12 fluid ounces of shampoo for $2.76. So we want $2.76 for 12. So we want to divide by 12, divide by 12, get a 1 on the bottom, 1 ounce, UNCE. We need $2.76 divided by 12. And that's 23 cents. And you should know by now that when you go to the grocery store to buy something, one bottle may be cheaper, but it may be a lot bigger or a lot smaller. So you have to figure out the price per ounce to see the better value. And we, moms, dads, when we go to the grocery store, we do things like that because we want the better buy. Okay, number 7. Which is the better value? 2 books for $15. So $15 for 2 books, or $45 for 6 books. So on this one, we're going to divide by 2, divide by 2. So we get a 1 down here, and we get $7.50. Down here, we're going to divide by 6, divide by 6. We're going to get 1 down here, and what's 45 divided by 6? $7.50. So what are we going to say? They both cost the same, because $7.50 is equal to $7.50. Okay, teachers, this is about 27 minutes long. In the remainder of time that you have for class, you have page 303 that they can work on, and the vocabulary and the reteaching page to work on, and there's also a quiz provided if you choose to use that. So please use the remainder of your time and continue to work on unit rates and make comparisons of those. I think the students will find this a pretty easy lesson and can get this figured out pretty quickly. All right, I'll see you next time for 5-7.